Okay, I'm going to go over this 2500 watt inverter installation that I did in my Rockwood Minilite 2304. It's the one that has the bed in the front that folds up. And what I had to do to get this mounted in here, this originally had like a drawer that came back about this deep. And I took the drawer out and put hinges on the front, and now I use it for a little storage space. Gave me room to put everything in here then. So basically it's got a charge controller, 60 amp, 2500 watt inverter, and 2 deep cycle batteries. The inverter is, I wanted this particular style because it has a hardwire AC output. So I go from the it's hardwired down in here, and I go directly into my circuit panel behind me, and I'll go over that a little bit, show you what I did there. I had made up my own cables here. Now these are not they're not the kosher. These, I wanted a heavier cable because you know, for maximum output, and it was well over 100 amps of output. So I went with some larger battery lugs, and then there's 3 number 2 copper cables that I crimped in here on the lug, and then they went into the input of the inverter over here. So they're somewhat flexible. Now if you go with a welding cable, which is better, but money, and I had this laying around, so I went ahead and did that. The cables they sent with the inverter are kind of useless to use to hook up to the battery. They're not heavy enough, but I did use them to run these batteries over to the RV charger, the DC converter, which is built into the circuit breaker panel here. I went ahead and ran cables going over to that. I had to mount them underneath the camper through some conduit and come back up. So I've got those over running into here. So I've got these batteries tied in with the 12 volt charging system, in which I can use these batteries as and charge them up and run my 12 volt camper, you know, everything in the camper, that's 12 volts. So what I have got here is there's a cooling fan. I put this in as an auxiliary one, but this thing runs really pretty cool. We've been using it now, doing some boondocking, camping, and I mainly wanted it for the microwave and my coffee maker, little coffee pot, electric coffee pot that I have, and it works real well for that. And it also, I wanted this model because it has a remote control. Granted, it's not much of one, and I'll show you that. I'll go through with the camera and kind of go over this stuff, but it does allow me to turn off and on, and when I turn the inverter on, this fan will come on, which it just did. There's a little hesitation, and it just blows some air through there, and you know, keeps the air circulating. I also, you can see down below, I mounted 2 register grills for a heating system. Cut some openings and mounted them in to dress it up, to give it a little ventilation in here. Now these batteries are sealed, so there's not, you know, any problem with the sulfuric gases or hydrogen gases getting in and igniting and blowing up the camper or something like that. So you want to make sure you get the right type of batteries and do something like this. So I'm going to go over take the camera go over some of the details here of how they did stuff. So we'll do that next. Okay, I wanted to show you the setup I have over here to control the batteries and to get the power to the circuit breaker panel here from the inverter. First off, this is the battery. I've got two 50 amp disconnect switches that are wired into the DC charger built in here for the camper. To charge it was originally to charge the battery that's on the tongue, but I wanted to have the option of charging the batteries too in the inverter system from AC. If I have to use a generator or something like that, then I can go ahead and charge them up when I'm boondocking if I don't have enough solar power. So with that, I can the front one goes to the front battery on the tongue, and the this one goes to the two batteries in the inverter system. So this is off position, and this is the on. So I've got the option of having all three batteries together, which I don't want to use the front battery when I'm using the inverter because the wiring is not heavy enough from the front battery to pull the load that it's going to be calling for, the type of amperage for the inverter. So I always make sure I've got this one off if I'm going to be using the inverter itself. But if I'm not going to be using the inverter and I want to just run, make sure I have plenty of 12 volts for boondocking, now I can go ahead and kick in all three batteries together. So it's a good option, and you even got this option with this switch that you can just pull it out, and this handle comes out, and nobody can mess with it then. If you got small children or something that like to play with stuff, I guess that's a good option, but I haven't found the need for it. Then over here, I'm bringing the AC into this 20 amp breaker right here. Now that gives me, the breaker will trip at 2400 watts, so it kind of protects the inverter itself from being too much being pulled through. The inverter has its own protection system and everything too, but what I've done was I made this little transfer switch. It's an interlock, so the breakers can't be turned on. This is the 30 amp is from shore power, and the 15 amp goes to the battery charger. Now I don't want either one of these on when I'm using the inverter. If you have shore power on and turn that breaker on for the inverter, then you could damage the inverter. It won't like AC voltage going into it. So what I got to do is turn off the breakers here, flip this up, then I can turn that one on. Now you notice the lights went out. That was because I had these off. So now I'm running on the batteries only, and I have power. I can turn the inverter on now, use my microwave and coffee pot. The whole AC system here is powered then. So I've got, I even have the air conditioning unit. I made it, forgot I had it in the inverter system, and had it on and accidentally turned the AC unit on, and it actually pulled it, and ran, but wouldn't run very long. So all of the breakers in here are all powered, microwave, and I installed some extra outlets in here in this camper. I may cover some of that stuff in a later video, what I've done. But the interlock is pretty simple and not hard to make. So then to turn the inverter breaker off, slide this down, and turn these breakers back on again, and So now we're back on shore power. So that's how that works. Okay, I'm going to go over this solar charge controller. I mounted it on this board. I had to mount this board on the side in here to be able to mount the solar charge controller to it. They don't want this mounted directly to combustible material, so there's spacers behind it, mounting it out away from that. The input comes from 4 100-watt solar panels that I have mounted up on the roof. Now I brought the cables down through the wall behind the dinette here, and on the back side is the shower. There's a vent pipe for the gray water that runs up through that wall, so it's a little bit wider. I drilled a hole through the roof down through and dropped the cables down inside here, and basically it's these two right here that are coming in. I've got a 40 amp fuse, input fuse here, and from the solar panels, and then the output of the charge controller goes to the batteries. There's a 40 amp fuse. The inverter, you see this orange wire, and that's a 10-2. I didn't need to go that heavy, but I had it, so I went ahead and put it in. Before I fixed this floor and put the foam in it to give more support again, there was channels, and I described that in a previous video on the repairs that I did on the soft floor of this camper. But there was, I pre-ran, before I put that foam in, I ran some wiring through there, in preparation for installing this system later. So my AC cables are running through there. The DC cables, I had to run a piece of conduit with 2 LBs underneath to run from the batteries here. I've got a larger fuse back here, you can't see it, and it goes over to the DC charger that's the converter that's in the RV electrical panel over here. So that's basically the setup here. Like I said, it's a mess of wires in here. It's actually a lot cleaner. It was really a mess beforehand because the factory just doesn't do anything at all to dress stuff up. So that's this setup. Okay, I wanted to show you the this is the remote control that came with the inverter, and it's connected with a cable, and I had to drill a hole through the wall, drop the cable down through, drill another hole down below, and connect it to the inverter. Now this originally came with a much bigger box behind it and surface mounted. It would have stuck out way out here. So I eliminated the box. I had to, there's a circuit board that the cable plugged into. I had to trim it a little bit to fit through the hole, but everything fit down in there, and then I just screwed this to the wall here, so that dressed it up a lot and makes it look a lot better. And it's just a simple on-off control. Now it has a green light when it's working and a red light when there's a problem. That's that end of it. Okay, I'm just going to sit here and go over a couple of electrical things with this, and kind of let you know what you can expect. The batteries that I'm using in my system were deep cycle. Now you can get AGM batteries, you can get lithium batteries. The 2 batteries I got are in parallel, so it's 12 volts, and the 2 of them together I got about anywhere, kind of hard to figure with exactly, but 160 to 190 amp hours with those 2 batteries. Now in electrical world, everything revolves around watts because that's the only way you can change from one system to the other easily. So what I have with those batteries, I got about 1900 to 2200 watt hours approximately. Now that's based on a 12 volt, but the voltage in this system, you're going to start out with a higher 13 volts. You can go all the way down to, I think the inverter kicks out at 9.5 volts, which is getting pretty low for flooded batteries to drain to. But so this is approximately what you got. So I'll take the microwave that I have for an example. It's 1350 watts at 120 volts. Well, you know, with the inverter, you're going to be pulling the same amount of wattage, but it's going to be 12 volts. So we run the microwave 3 minutes to heat up a glass of water for my wife's tea in the morning. So that's about 4050 watts, give or take, of power being drawn from this system. So if you're going to look and then to replenish that, and I've got 400 watts of panels on the roof, and typically you're not going to get 400 watts even in full sun. You're going to get a little less than that because there's some loss, and just you know, you got to have exactly the right angle to the sun to get the maximum power out. So I figured maybe about 300 watts when I'm in pretty good sunlight. So it's going to take about 13.5 minutes to replenish that 3 minutes that I used the microwave. It's going to take 13.5 minutes of charge time from the solar system. Now if I did the microwave for say 10 minutes, then I'm drawing 13,500 watts. So I'm going to need to go about 45 minutes of solar to charge that back up into the system. You know, somebody can get on there and correct me or whatever, but these are ballparks for people that can understand a little bit. You know, it may be less if the batteries are fully charged. It'd be less solar time, and if they're a little low, it's going to take a little longer. So the inverter that I got is 2500 watt. It's a pure sine wave inverter. It's strictly 120 volt output. The price on it was real reasonable, and I'll put, like I said, I'll put all of the things that I got from Amazon and eBay and list them in a comment at the end of this video. I am going to go ahead and show you for the end of the video the solar panels on the roof, just so you got an idea what I did there and how I did the cable going down and what I used to seal up around the screws and everything, so that you know, you don't have any leaks or anything. Okay, so we're up here on the roof, and these are my 4 panels, 3 in a line, and the 4th one over there. They're all wired in series. I think that's about 18 volts per panel, and the charge controller would take up to 100 volts DC, so I'm well within the parameters for that. Right here is the sealant that I used to, you can kind of see where I sealed the mounting brackets, where the screws went down into the roof. This is the stuff they use in the RV industry to seal up the edges of the roof and everything. My nephew works for an RV company, and he got me a couple of tubes of this. So, and I'll try to find that and list it, but I'll list the name at least. But it's Alpha Systems Incorporated non-sag. It's 1010 non-sag sealant. Okay, and I'll list the information in a comment. I'll find that. So I went down through the roof, just drilled it's just a 1/2 inch hole, and then this stuff really hardens up pretty good, and it is very durable, so it shouldn't be any problem leaking. It's basically the same stuff they used here. This is a lot older on here, but I think this was resealed. We bought this used a few years back, so it's already been resealed once. Anyway, that's basically my solar panels on here. I hope you enjoyed the video. If you did, please like and comment and even subscribe. I got something like 13 subscribers so far. So anyway, thank you for watching.